Oh, okay. There's our airplane.
Yeah, so hopefully, so we have this. So we talked about the angle of attack and changing the position of the wing and also the tail. So again, if I go to edit here, I also can change the angle of my tail here. So for example, 0, if I put a 10, it become like this. So if I put it to -10, you can change it. So usually we'll keep it at 0, but we design in such a way that it can provide the stability that we want.
Oh, okay.
So this is a model of the airplane. So now what else we can do? I can add the second wing here. So I can right click, current plane, edit, and this is a biplane. So if I go to the biplane, so let's say I want to add a wing at the top of this wing. So if I go to the define, again, I can add any dimension that I want. So I make it a little bit smaller. So I will add the airfoils here. So exactly like the first wing that we designed.
Now, should the airfoils, if I do a biplane, should they match?
So it depends on the design. So for example, how much lift you want, what is the total weight. But this biplane configuration is no longer efficient for recent designs. Yeah. But these are for old World War II. So they were thinking that maybe adding the second wing, it helps to get extra payload. But they said that they found that eventually it's more efficient that increase the wingspan than adding two wings at top of each other. This is the main reason that we no longer see those type of airplanes. But here I just want to show you that it's possible. So if, for example, if this is my wing, let's make this one 0, a tapered wing. If I save here, so if I save, so it will become right. So if you want to make it at the top of this, you need to change the position. So for example, X, I'll put it as, let's say 50 centimeter. At the Z, I put it 20 centimeters. So it becomes like this, right?
Okay.
But for sure, you need to start to connect this to this, right? So, but the software doesn't have, it's neglecting those parts. But this is like a biplane configuration if you want to make it. Or you can make a tandem wing. So you can make this to 0. So you have two wings after each other. So this is called a tandem wing.
Tandem, yeah.
Right. So let's say that we want to right now forget about this wing.
Definitely.
And I will save it. So let's say this is my first airplane, right? I want to make different airplane and run the analysis and compare them together. So if I go to the plane, there is something, if you go to current plane, right? Or if you right click here in the current plane, there is something that's called duplicate.
Oh, okay.
So I can duplicate this. I want to keep this, make a new airplane. If I select duplicate, so it's a plane 01. So now if you go here, I have two airplanes here, right? So now I can mess with one of them and change it. So now let's make just the other shape of the tails. So if I go to the edit, so I'll see that how much, okay, it's going to be 60. So now here, I want to make this one 60, so it's -25. So this should be 35 and 35. I make my body like this. So save, it become like this, right? So just connect it to here. So let's say that I want to move this one inside of the wing, right? So I can go to edit. So now this can be 60, this can be 65.
Oh, okay.
Right, so you can make like this. So now my wing has an angle of attack, my tail doesn't have, right?
Right.
It has a 2, so now I can put 2 here. So now it would
And
be,
they match.
it would be matched. Yeah, and the main reason that this is like this, because is this distance. So if I make this one 0, this one 0, so now it's matched. Okay. So let's say that you wanna get, you wanna have a flying wing. You don't wanna have horizontal tail. You wanna just have 2 vertical tail. One this side, one this side, right?
Right. That makes sense.
So in order to do this, this is
Two-sided.
two-sided fin or double fin. I think two-sided fin, and the Z is in this direction. No. So maybe I need to collect a double fin, or yeah, double fin.
Yeah.
So in the double fin, the Y, so what was the distance from this here to here for my elevator is 40 centimeter, right?
Right.
So now here I should have 20 is exactly like what it is. So let's put 20 first, see what would happen. So 20 is in the middle. If I save it, yep, it should be 20. Do you see that I made this shape of tail?
Yes.
So now I have 2 vertical tails. And I can make this airplane. So I can, again, duplicate this, mess more with that. And then let's say I want to move this one here and here. And then I don't want to have this tail. So I'm going to edit. So I don't want to have elevator. So I'll get rid of that. I want to move this one here and here. So our wingspan is 100. So if I put 100 here, if I press save, so they become now outside of my wing. So I want to make.
So I think it was because it was really only 85 with the angle. So we need to change that to 85.
Exactly. So here we may push them a little bit backward. So if I say 85, yep, 85, maybe 80 should be fine. So we can actually find exact value with having the dimension. Yeah, 80 is really good.
Yeah.
So now I made this airplane, you see?
Nice.
Something, if I change the body, I can get exactly like this shape. So now what we can do, I want to make this airplane as well. Duplicate, set airplane 04. So now what I'm going to change here in the tail, I make the Z0, and I will see 2-sided fin. So now you will see something like this.
Oh, okay.
Right? This is a 2-sided fin. It means that you have one at the top, one at the bottom side. So it's like a tail-seater airplane. There is some type of airplane that they are like this. They are landing like this, and they have a ducted fan at the back that they will be vertical airplane. So you can make any shape that you want here. You can design a car here. You can model a car. Seriously. I mean, so in the airfoil that we selected, so we can integrate in different sections, and we can make a car. We can make a spherical shape. We can make a cylindrical shape. Any shape that you want, you can make it here. So this is a geometry that you can play with that. So now I have 4 airplanes that I want to analyze them one by one. So there are, for analysis, we just work with the define an analysis. The stability analysis is more fundamental. It needs some control perspective or something, which is out of scope of this course. But in future, if I propose any new courses for the continuous of this, if you like the topic, I mean, we can work together to understand those. So define an analysis. So let's start with the simplest one. So let's say I want to make the analysis for this airplane. So if I go to analysis, select define an analysis, before going to that, you need to do adjustment in your software. You should go to advanced setting.
Okay.
Can you do it now? Because it's just one time.
I actually, if you're sharing your screen, I can't access anything else.
So let me stop it. And
Okay.
so can you share your screen with me? So I'll show you what you need to do.
Oh, okay. Because I played around a little bit while we were on break. Let's see. Share screen. I'm disabled from sharing my screen.
Oh, sorry. It's a new Zoom meeting. Okay. So.
Oh, I know. I had to do it too because I got in one of my lectures towards the end of the term. I got bombed by somebody who was not a student, so I had to turn all that off.
So
it was hard because my kids, my kids were sharing their screen and showing me their work and stuff.
How many students do you have?
I had 100 last term.
Oh my gosh,
I should
wow.
have. That's low. Back when I taught at Volcano Vista, they would put like 38 kids in a chemistry class.
Wow, that's
Here at this school, they only put a maximum of 18 kids, so I'm much happier. It's a much more reasonable number. Okay, so where do I need to go?
So save this. And okay, press save. That's great. So now go to analysis. Yeah, go to that airplane first.
Oh, to the plane?
No, shape of the airplane. Go down, click.
This?
Yeah, click here. You will see just a white, and you will see your airplane. So now.
I just got started.
That's really good. So now click on analysis.
Over here?
At the top. Go to advanced setting. Click on store points outside the polar mesh. Down, yep. Click on OK. That's awesome. So now this is just adjustment that I spent 2 months to find this in 2008 when I was working with this.
Oh my gosh.
So otherwise it doesn't give you some results. So now let's do an analysis first, and then we can do one for you.
Okay, so I'll stop sharing. We'll look at your analysis.
Yeah, I can do this.
Okay, great.
So now I want to analyze this. So I'll go to analysis. I will go to define an analysis. So again, you have 4 types. You remember the airfoil, we had 4 types?
Yes.
So here you have 4 types. So, and there is a typo here. There is no type 3. So type 1, you are fixing your flow speed. The speed of your airplane. Is it flying with 10 meters per second, 20 meters per second? So whatever you want, you put it here. I don't change the alpha and beta here, but I'll talk about beta, which is called banking angle. I'll explain about this later on. So this is for type 1. You are going with the fixed speed. Then you will go to analysis. There are 3 different analyses here. LLT means leaf line theory, horseshoe vortex lattice method, and ring vortex lattice method. So what are these? I may have a PowerPoint to share with you. Hopefully. Yeah, I will share with you this PowerPoint with talk about, just for your information, I'm not going to ask you or something at all. And this is just something background behind this software, so I will share it with you. It talks about the background of this software. The theory which this software is using is called leaf line theory, is the LLT. You remember that graph for the CL, I said that till 5 degrees, once you're increasing the angle of attack, your lift coefficient is increasing linearly. It's like a line. So this is a leaf line theory.
Okay.
And there is a LLT, the advantage of or disadvantage of these aerodynamic theories. So this is something that, and for vortex lattice method, is more fundamental. I skipped it here, but what I'm going to do, I will share this with you. So you will have it in case for just
thank you.
information.
Yeah.
So LLT is neglecting the dihedral angle. And
Oh, okay.
just consider the 2D effect. The horseshoe and the ring vortex, they're almost similar, but a little bit different in the boundary conditions. But you can do with the three of them, and you can compare them to see how they act. I'll do it
right.
for you. So then remove this. Since you have a body, you want to consider a body panel, right?
Right.
So I'll consider viscous. So let's do with the horseshoe. Inertia, so this is related to stability. We don't actually change this. Once you're selecting this, you can say the change of the name. So it's a T1, it means type 1. The speed is 20 meters per second, and you are doing with the VLM1, right?
Right.
VLM1. If I select VLA2, so this would be VLA2. If I put it auto, it would be VLA2, right? So it's exactly like the airfoil that we discussed. Reference dimension, we don't touch this. It automatically software funded. Aero data is the viscosity. Sorry.
Bless you.
It didn't come. Thank you. The rho is the density and the viscosity. So this viscosity is kinematic viscosity. Oh my gosh. And if you want to consider the altitude and the temperature effect, so for example, if an airplane is flying in 10,000 feet from the sea level, with the airplane which is flying is 20 meters or 20 feet from sea level, it will be different, right?
Okay.
So I can say from altitude, so for example, say that if my drone is flying in the 1 kilometer from the surface, so the air pressure would change, the air density would change, the dynamic viscosity would change. The kinematic viscosity is that if you divide the dynamic viscosity by air density, you will get kinematic viscosity. I can prove you here.
And is this 1,000 meters off the ground or 1,000 meters above sea level?
Off the sea level.
Okay.
Off the sea level. So, and this is applicable to altitude less than 11,000 meters. Because you are in the troposphere region. If you go more, this equation for
right, it doesn't work.
Finding, it no longer works. So the kinematic viscosity, do you know kinematic viscosity?
Basic, very basic.
Okay, if you divide dynamic viscosity by air density, you will get the kinematic viscosity. So now I want to show you here is 1.76 times 10 to power minus 5. So I'll skip that, divided by air density, which is 1.11163. You see it's 1.58. You see here?
Yep, and we keep our 10 to the negative 5.
Exactly. So this is something that you can consider this if you want to have from altitude. So you can consider this effect. I put it 0 right now. The ground effect. Do you remember I was talking about a bird which is flying over the ocean so close to water to use the ground effect?
Right.
So this is something. I mean the distance from the ground. So this is something, if you want to include it, in your analysis, you can put the value. But if you fly more than 5 meters or 2 meters from the ground level, you no longer have that ground effect.
Oh, okay.
Our airplanes flying, so we don't do this. Extra drag. So let's say your airplane has a landing gear. It has some other components. So you can add their surface area, their drag coefficients for each one of these components, and you can add them. Since you don't have anything for this airplane, we don't need to add anything here, right? But if you design a big airplane which has other components like big payload, like missile, rockets, I don't know, the weapons. So you can add them
A
here.
camera.
So yeah. So then once this is done, everything is okay to run an analysis with the condition that you inserted here. So I will press save here. Then again, like Air Force, I press sequence from -5 to 25 degree with the increment of 1, right? So now if I press analysis, see what you will get. You are running analysis for different angle of attack. And if I press on CP 2 times, so this gives you the analysis here. This is the angle of attack -5. If I put it 0, this is angle of attack 0. This shows you pressure distribution, right?
Right.
Pressure distribution. This shows you the lift distribution. It shows you how the lift is distributed over your wing. So I just show you this, right? So you see that your tail, it gives you negative lift. So it's going down. So maybe you need to, adjust the angle, or maybe it's good, depending on how much weight you are considering for your airplane, right? So if I show you this view at angle of at 0, this shows you how the lift has been distributed. Do you see this is a distributed lift over your airplane, right? If I put it ISO,
Okay.
so do you see this color? This shows
Yeah.
you the pressure distribution. So for example, at the bottom side, you should have a higher pressure than the top side.
Right.
Here, how the pressure has been changed in different subpart. So this gives you the pressure distribution. So if I change my angle of attack to 6, you see that how would happen? The pressure at the top, it's lower.
Yeah.
Now it get more lift. So if I put it 16, become like this. If I make it negative, so then it doesn't give you too much lift. If I make it -5, so it doesn't give you any lift, right? It's downward. Yeah, and specifically for the tail, right? But once I increase it, you see that the tail is increasing, generating the lift, and this is generating lift both in the same time, right? This is a lift force which is generated and helps your airplanes to take off. If you
Right.
want to see, there are 2 diracs. There is one induced dirac, which comes from the 3D effect. There is one viscous effect, come from viscosity. This is a viscous effect of your system, and this is the induced drag, the drag because of the lift. The combination of these two, it shows the total drag of your airplane.
Wow.
Right? So if you want to see the downwash effects, this is something that I was talking about this in the first lecture when I was talking about birds when they're flying in V formation. So because of downwash and upwashes, this is downwash effects. If you want to simulate the flow simulation, I can select a stream here. So if I now go to this view, it shows me how these streamlines are changing around my airfoil, around my body, and everywhere. You see here? This is a flow simulation. Right. So now if I press animate, shows that how this with changing angle of attack, this would change.
Oh, that's cool.
Okay. So now if I make it, for example, 14, you see that how this would change. These are the vortices that they are generated in your wingtip. If you want to see the flow in each panel, the surface velocity, I can show this. This is the velocity of the flow. Oh, let's make an angle of attack 0. Once the flow is touching this airplane. So if you want to see how the lift is changing versus angle of attack, you can press animate. It shows how this would change. You see the angle of attack here?
Yeah.
is increasing. And here, the CL means the lift coefficient, CD means drag coefficient, efficiency of your drone, CL over CT. It gives you all the aerodynamic characteristics of your wing. And these are for induced drags. So these are analysis of the airplane. So here you have the geometrical characteristic, your wingspan. We didn't add any weight, but you can add weight to your airplane. Let's say 5 kilogram, 2 kilogram. Wing loading is the dividing the plane weight divided by wing area. So here it shows 0 because I didn't put any weight on my airplane. Aspect ratio, so it shows the number of elements or mesh. It shows you everything here. And this shows you the velocity and the rest of the thing. So now, if I go here, which is OP point view, you see here?
Uh-huh.
So if I press here, this shows the lift distribution here. Here you can see the total angle in the span-wise. If you see lift coefficient, how it's changing span-wise. This is for tail, this is for your wing, right? It shows the value of the lift in each section, or total drag coefficient, how it's changing in each section. So this is some useful, or Reynolds number, how it's changing, some useful actual information that you can get from here. So, but the only part that we may, go more over that is in the polar view. So do you see here is a CD over alpha? So once you do this, it shows you something like this. So once you're running analysis, it shows you something like this. So it shows you 4 graphs. If you want to just see one graph, the graph 1, you can select here graph 1. Is exactly like airfoil. Do you remember in the airfoil, you will just double click in the variable. You can,
and we could change the
CL versus alpha, CD versus alpha, right? CD viscous versus alpha. So you have you want to see the forces, like say the lift. This is FZ in the Z direction, shows you that how much forces you are getting. You can improve the quality of your figure here, right? Change the color. It's exactly like airfoil. So this is a FZ, right? FZ is the lift.
Right.
And the FX is the drag. So if I select FZ, this shows me that at angle of attack 0 for my airplane, it can carry about 3.6 36 Newton. So 36 Newton divided by 9.81, the gravity acceleration, 3.7 kilogram can be the weight of this airplane.
Oh, nice.
Right? I mean, this is explanation.
That's about 8 pounds.
Yeah, if your airplane is, let's say, 8 kilogram, about, I don't know, 15 pounds or 14 pounds, your angle of attack should be about 5 degrees.
Okay.
So once your airplane goes with this angle, it will be able to carry that payload, right? So this is a drag. Fy is if Fx is your drag. It means that how much thrust you need, right, to compensate this. If I go at 0 degree, you have 1.5 Newton, 1.5 Newton thrust force. It means that your propulsion system, this motor, should be able to provide this amount of force. And this is the stage that you are designing this propeller, right?
Okay.
There is a software, it is called eCalc. I can show you here. So eCalc if you go for eCalc simulation, there are different types of the airplanes here. So one of them is a multi-rotors, one of them is for airplanes that we are dealing with. These are the propeller aircraft that we are looking at them, or fan-based aircraft, or for example, setup finder. So if you go here in the software, I mean, this is a commercialized, so I mean, it's $7. I actually bought it for multi-rotors for a proposal. But just to show you that this is for another class, just to explain you, you can put the information of your airplane here, and it which suggests the size of this propeller, right? The type of the motor that you are using, all the component, it shows you there. So this is something online that just for your information that you can use. What type of battery you want to select for your airplane, what type of electronics, motor. So once you put the information from here to there, this software gives you some recommendation. So this is the rag force. If you want to see, for example, CL over CD, this is CL over CD. It shows you that where you have the maximum CL over CD. It happens in a small angle of attack about 1 degree. If you want to see CL versus CD, right? So any graph versus another graph that you want, you can draw it here. So, but these are the meaningful that, I mean, for our course that we are more dealing with. These 3 parts is more for control and for stability, which this is another course actually, is for flight dynamics called or autopilot design, that this is somehow again out of the scope of this material. It's more fundamental. I mean, it's like vibration or lots of mathematics and control. So I skipped these 3 parts in the software. But these 2, specifically this part, which is polar view, this is the main part that we are working with. So if you want to see, save this graph, you can right click, current graph, export graph. You can save them as the CSV file in the Excel if you want to read the data, or you can go here, export result. If I go here, so the result for our airplane will be saved. So let me save this and I will open it and show it to you. So let's say, so put my name here, stuff of plane. So I save it in my desktop. If I find it. Okay, find it. So if I share my screen again, do you see here? These are gives you all the results: alpha, beta, CL, CDI. So you have all the value. So for each angle of attack, you will be able to read this value. Right? But the graph is better because it's more visualized. So it would be more interesting than those numbers. So now if you want to see the 4 graphs, so you can go to graph, say that you want to see the 4 graphs. So I want to see CL versus alpha, CD versus alpha, momentum coefficient, CL over CD. So this is the analysis through the VLM1, right? So I want to do with the VLM2. So I can select this. Everything would be the same. Speed is 20 meters. The same data, I didn't change anything here. Click on the save. So here, this is, this is VLM2. I need to do VLM1. So VLM1. So, okay.
Didn't we already do VLM1?
I need to check because maybe I changed the name to 2.
Oh.
So I guess this is some some change, but they should be inverse for sure. Or maybe they are the same. We will find out now. So we did VLM1. If I go back here, yeah, you see This is VLM1. So now I need to do with VLM2. So I go to analysis. Here I'll set ring vortex, save. Let's change just VLM. Actually VLM2, it will be resaved on that. So if I save this, so this is a VLM1. I forgot to do the body. So I can remove this and run this analysis with body again. So I'll rewrite this again. So now this is with the VLM2, right? So now if you look at the difference, it's so a small difference. You see here? A little bit in the CL and CD, but in CL over CD, you can see this. These are two different aerodynamic theories, right? But they are not far from the LLT. So now if I go back and run this analysis with LLT, so now if I press this, in LLT, you cannot see those colorful images, but you will see the differences. You see here?
Yeah.
So if I make a dashed line and increase the width,
Okay.
and I can here say VLM, I can change the style, increase the width, VLM2, increase the width and style. You see here? So maybe change the color. So I have the three graphs here. You can compare them. These are three aerodynamic theories. So LLT is far from VLM1 and VLM2, right?
Right.
So then if you want to see any analysis, you can just select here, and you will see for different theories, for lift distribution, or for other aerodynamic characteristics. So these are all in the same angle of attack. So the last thing that I want to mention is let's select, this is the first airplane. We want to select the second airplane. And I want to analyze this with horseshoe body. So the same process, but for different airplane. I want to show you that what change you will see in the graphs. You see,
right, because we've got the different tail.
Yeah, exactly. And let's do for other plane. It's horseshoe 2.
Ooh,
And
solid yellow.
Yeah. And the last one.
That tail makes a difference.
Tail makes a difference, exactly. So if I make the angle of attack 0, show the streams, you see how this is big mess here. So this is something good about results. So now if I go to polar view, you will see all of this analysis here.
Oh, okay, nice.
Right? So you
can
will be able exactly to compare them, to compare all of them together. So this plane 4 is a little bit, the lift is stalling earlier, you see here. It's because
crash.
Yeah, crash. So this is something that you can interpret from these results. So let's select our original airplane. Yeah, I mean, this part, stability and this parameter, these are a little bit out of scope of this material, but I want to show you something fun here. So, okay, first module. So for example, I want to run this analysis, longitudinal stability, let's say lateral stability. If I press, this shows me if my airplane is stable or no. But since we didn't put any values here, so it doesn't give me anything. So I mean, including the weight, the location of the weight distribution, the center of gravity. So this is something is more related to stability. So it's a lots of fundamental behind that. So, but these two is just for analyzing those. So the last thing that I want to show you, I want to add flap to this.
Okay.
So in order to add flap, I will go to the file, direct foil design. Let's add flap to our tail and to our body, to our wing. So I'll go to NACA 2412, right click here, set flap, trailing edge flap. Let's say 30 degree, 80%. Click on OK, set flap. So this is flap down. I want to make it flap up. So I'll do it again. Right click, set flap. Mine is 30. Okay, sounds good. Set flap. Click on OK. For NACA 006, set flap minus 35, 80, set flap, flap. So I'll go back. You need to also run analysis for them. If I add in the airfoil, so this is a CL for the flap one with the non-flap one.
Wow.
For just the airfoil. So now for this, we'll do the same. Since this is a flap up, the lift is decreasing. And the flap up, it means that this is going up, right?
Right.
Going down. So once you're going down, your lift is increasing. Once going up, your lift is decreasing.
Decreasing, so you can land.
So now, if I go to wing and plane design, I want to add flap to my wing and to my tail. So I will right click here. I will go to current plane, edit wing.
Okay.
Correct? So now let's go to the top view and see it from the top view. So I want to add flap from here to here, right?
Right.
So I need to add a same, so I have one cross section, right? I have one section. So the airfoil, which I am adding to this, one should be with flap, the other one without flap. So now I will add inter after section 2, another section, but I'll put it as similar as my section 2. So 30, 30, 20. But here in the airfoil, instead of 2412, I'll select 2412 with the flap.
Ah.
Right?
Right.
Now for, I want to do, let's say, insert after section. Let's just want to make it till here, right?
Right.
So at 65. So I will add one more because I want to have 265 here.
Okay.
Or let's do with 82 to make it bigger. So now I need to make this one 82.5. So the same thing, 15.75. And this is 50, correct?
Right.
So now this should be set flap. This should become as a normal, right?
Right.
So now if you look at here, there is a flap here, you see here?
Yeah. Nice.
So now if I save this, my airplane has a flap. So now let's do for the tail. For the tail, it would be easier. Current plane, edit elevator. So now I will add change the whole airfoil to 00 flap.
Oh, the whole thing.
Yeah, right? So now it becomes like this. So now if I press save, so my airfoil has flap. So now I will run the analysis for this flap, see that what would happen. So, okay, save. The same analysis that we did. Set with flap.
Flap.
Okay, and analysis. So if you want to see the lift distribution, so what is the change in the viscous? Change angle of attack to 0. So do you see how this changed?
Mm-hmm.
So now you see that your lift is negative. So your airplane wants to get up.
And you could compare this analysis to just the original plane analysis.
Exactly. So
if you just had those two, just to see how much space it's going to need to slow down to land.
Exactly. So
okay.
This is a difference. You see how much big difference there is here?
Oh yeah.
A small flap.
Wow. Wow.
So this is something related to flap. So anyway, let's do with you as your one of your assignment that I can help you with that. So you can share your screen with me.
Okay.
Yeah.
Okay, so I started messing around, and this is the wing I made.
Yeah, that's great. So let's go to option, please.
Option.
Mm-hmm. Select preference. Sounds good. Go to units and change the length to centimeter.
Oh, okay.
Because your wingspan is now 30 meter.
I'm making a big plane.
Yeah. So now close. So for the area is fine. For the rest is fine. So area, you can put it back to meter square.
Put it back to meter squared? Oh,
yeah.
Okay.
Just the wingspan. Meter, down, down, down. Yep.
There it is.
Then close it. If you are, go with the inch or foot or
millimeter. No imperialism for this girl.
Yeah, me too. So now right click there. Go to current plane, edit wing. Sounds good. So now you see it's 1,000, so make them 100 and 150.
Okay.
So divide everything by 10. So to make it smaller, 150. Those should be 30, 15, 10, 50.
Oh, okay.
Yeah. So now, so if you go down, there is a reset size, or you can zoom in. Do you see the isometric view? I mean, the zoom doesn't let me to see the bottom side of this. So here,
I don't know how to zoom.
So here, do you see X, Y, Z? You have the axis in the down right side. Yeah, click in that it is written.
Oh,
yeah.
here.
Yep. So can you click in? There is a reset scale. Click on reset scale. Reset scale. Yeah. Click there. So now, did you?
Nothing's happening.
Really?
Yeah.
Click isometric view. X, Y, Z, the top. The fourth one. The next one. Yep. Click here. So what others? I mean, reset scale should work. So scale wing. So can you zoom in with your keyboard? I mean, you can make it bigger. So when you want to zoom in your laptop, if you use like this in the place that you are working as a mouse.
Yeah, that's probably better. No, it just moves it around.
So that's fine. So click on the save.
What's funny is it'll blow everything else up. There we go.
Yeah, with the mouse is really easy. So
Yeah.
can you click on the save?
Oh, there we go.
Here you go. So
There we
now, as I can see from here, you have not added the airfoil to your tails. So right click
No.
there.
Okay, so click on the tail.
Right click here, go to current plane. You can go to edit elevator. I mean, you can keep the same size, or if you want to change them, feel free to change them. But the thing which is important, the foil, you need to add airfoil. Yep, here you go.
Okay.
Then click one
And
more time.
I want to do the angle. I want the
For the
front.
tail, yeah.
Yeah.
Do that.
So
I
that's
forgot to discuss this. Make your dihedral angle 30 degree.
my dehanger. Okay, 30
Yeah.
on both.
Mm-hmm.
Okay.
So then click on save. You can also apply texture to change the color.
Okay, do we need to go back to that to do that?
Yeah, right click, current plane,
Plane.
edit, elevator.
Okay, and that's reset the mesh.
So apply texture.
Oh, texture.
So it make it like a real airplane.
Right.
Click on the save.
Okay.
Sounds good. So do you want to keep the vertical tail here, or you don't want to do that? Because once you have this V formation, you no longer need vertical tail.
Right.
So go right click there. Current plane, edit.
Fin, right?
No, just edit.
Oh, just edit. Okay.
Yep. Remove that fin. Yep.
Okay.
Go to action in the body. Top.
Okay.
Yep. Click on edit. So for the body that you have designed, you can apply texture as well to shows in the left side. It shows where is your cabin and where is the nose of your airplane.
Okay.
So if you want to change the body, I mean, feel free to play with that. If not, you can save it.
Yeah, I like the body.
So
Okay.
now click on the save. This is going to be your airplane.
It's got big wings.
So yeah, the wing is a little bit big, but you can actually revise it. So right click there. Go to current plane, edit wing. Edit wing.
Let's see what length
You
did I
can
put in these.
delete the 151. Go click on the third one. 150.
Yeah.
There is a delete section 3 in the top.
Oh, just delete the section?
Yeah.
Okay. That makes more sense. Okay.
So then you can make your wing like 80 centimeter.
Okay.
To make it a little bit fatter wing. Sounds good. So now click on the save.
Oh, there we go.
Yep, sounds good. So now let's do some analysis. Go to analysis.
Okay. All right.
Define an analysis. Let's say your airplane is flying with the speed of 20 or 15 meters per second, whatever speed you want your airplane goes.
20 meters per second is pretty good.
Then go to analysis. Okay, keep horseshoe, remove these ignore body panels. Then yeah, the rest should be fine. Save, go to sequence.
Sequence.
Yeah. There in the analysis, the right side.
Oh, this one.
Yeah. Sequence, press sequence.
Oh, okay.
Put a minus, let's say minus 5 to 30 degree. Minus 5. Yep. 230. 30. and change the delta to 1 degree. It means every 1 degree is changing the angle of attack. So now press analysis. Awesome. Close it. Click on the CP center of pressure.
Oh, over here?
Yeah. Click on this lift. Click on induced drag. Click on viscosity. Another one, viscous drag. Right here.
Where's viscosity? Oh, there it is.
Yep.
Okay.
Yep. And then click on animate. This shows you that how your airplane works. So now you can get rid of everything except CP and apply a stream. So we know we want to see the flow streamlines. You can click on animate again. Okay, remove lift, induced drag, and viscous drag.
And just do CP?
Just select a stream. Yep, and now now you can see the flow streams. So
Oh, wow.
you can select again different axes. Do you see X, Y, Z down? These are the different coordinates. X, Y, down.
Go down here.
Yep, click on that.
It's this one?
Mm-hmm.
Okay.
So this shows the back view of your airplane. Sounds good. So now go to show me the graph, the top part. OP point view. I mean, before going to there, you should click on the OP point view. There is a beside that airplane shape. There is
This one?
no. Go out of here. At the top, beside the side. Yeah, here. The next one. Yep, here you go.
Oh, okay, that one. Oh, sorry.
The next
I was
one.
on there. This one?
Yeah.
Oh, okay.
Sounds good. So you see your graphs here. So you see you have CL versus CD, you have CL versus alpha, you have CM versus alpha, you have CL versus CD versus alpha. You will see all of your graphs here. So now go to analysis again. We want to do with the other theory.
With the other what?
Define an analysis and go to analysis and press ring vortex. Here you go, save. And run analysis here as it is. Press, here you go. You got the result for that as well. So you have the comparison of between two aerodynamic theories.
They're very close.
Yeah, that's great.
Oh, is it?
Yeah, this was your exam. So I need to delete those parts in the lecture. The only thing that I want to show you, I forget, this software can be connected to the 3D printer.
Oh, cool.
If you go to a school, if you want to, I mean, teach this course there in your school or show it to a student and you want to make a model of this, you will be able to 3D print this. If I go to
wow.
plane, current plane, there is an export to STL. Do you see it here?
Yes.
So this STL is the format for 3D printer. So if I press,
cool.
You can print the main wing, you can print the elevator, the fin, the body.
Okay, so print them individually and then put it together.
Yeah, exactly. So if I press OK, so you will be able to save it as the 3D printer format. I think that is all for this course that we discussed here. I am going to give you right now your post test.
Okay.
we will answer it together.
Okay, I appreciate that.
And because this is something that they asked me to send it to Mark. Do you have, you send it to me the first one, I am going to
Yeah.
forward it to Mark. I mean, this is not just for the evaluation of the program.
Well, and the first one was really easy. I didn't know any of that, so I just picked A. They say when you know nothing, pick one letter every time.
So if you want to answer them again, the pre-test, we can answer it. It's up to you.
Okay. Yeah, that way we'll have you'll have a set for you'll have a post test.
Yeah, so I have
Questions?
post-test, yeah.
Okay.
Let me, because I have made, let me find it where I save it. Okay, it's going to teaching. So let me stop this.